Today we're going to be making a camera obscura, following a tutorial on YouTube, actually. So all we need is a Pringles can, something to hold the Pringles, parchment paper, scissors, and a thumbtack. Plus, got a little helper. So the very first thing we're going to do, we're going to eat all the Pringles, or you could just dump them into the bag. Open up. Barbecue flavor, best flavor. Eat those later. Out of the reach of your cat. So next thing we're going to do, we're going to measure out 2 inches from the bottom of this can. Watch out for crumbs coming down. Let's see. Take out our ruler. Measure 2 inches. All right, from there, we can start cutting. If you have a knife, like an X-Acto knife, that makes it a little bit easier and safer. Otherwise, cutting with the scissors is perfectly fine. I do happen to have a knife here, though. So let's see. Cut around there. Yeah. All right. Now we have 2 sections. The top section, hollow, bottom section, which doesn't have a hole in it yet. So next thing we're gonna do, we're gonna keep on cutting things to shape just to start off with. I'm gonna open up my parchment paper. This funky parchment paper from Safeway that actually comes in sheets, which is really convenient for cooking, but less so for making our camera. So take this parchment paper, get Mr. Onigiri out of the way. Say hi, Onigiri. We're going to cut out about the size of your Pringles can lid. So it helped you trace that first. Learn that from kindergarten arts and crafts. Got a nice little circle. I'm going to cut that. This you can cut a little bit inside the lines too, just because when you trace, you're gonna be drawing outside the size of your Pringles can, but it shouldn't make too much difference. All right. So, a little circle. Fit right about on the Pringles lid. So, next up we're going to use our thumbtack, poke our pinhole in here. So find about where the center is, give or take. Nice and easy. A little hole through. A little pinhole. I don't know if you can see this in the video, but I can see you guys. So counts for something. All right. Now with that, can plug up the bottom here. And I actually couldn't find tape here in my apartment, so I'm just going to be holding this here with our Pringles can. And now, lock out the light. Should be able to see what's going on. my previous can doesn't block out enough light, so some aluminum foil I'm going to wrap around it. Hopefully that should block out the light. It's probably blocking out the sound right now as I'm recording myself, so got that going for me at least. As best we can, stay together with that tape. All right, so now, ooh, that's really cool. So I can look around, see the images. There's still some light peeking through, but I see everything upside down world. Super cool. I don't know if you can see what I see. Camera does not show up very well on the camera, but here we have it. Simple camera Obscura. Cost me about less than $10. Get all the ingredients, and I have a full bag of chips that I can munch on. Thanks for watching. Oh, you're still there. So while we were gone, I was munching on some chips, and I also wanted to go over some of the math of how this pinhole camera works, how we can use it to estimate the height of objects that we're seeing through the camera. So I created this lovely little diagram. I don't know if you can see that there. We're going to estimate the height of this lamp here that I'm looking at with my camera. We can see my camera here, nice Pringle can shape. This line here represents our projection that we're seeing. So even though we're looking through the camera, we're looking at the image on the parchment paper that we cut out earlier. And then this line here represents the edge of the camera with the pinhole right there. So what we're looking at here, we're looking at a case of similar triangles and comparing these to determine the height. So I've labeled a few points here. Our first two are for the lamp. We have x1, y1, and x1, y2. X is the same on both these because I'm assuming the lamp is a straight object. It doesn't have any depth, even though I took the time to draw this very lovely base there. Lamp is a flat thing without depth. So they have the same x coordinate or distance away from our camera. It's just the two different heights there. And we're looking for the difference between y1 and y2. That's going to give us our height. Next 2 points we have labeled here are the pinhole, which we're assuming is 0, 0. This, by changing our frame of reference to the originating at the pinhole, we make our math a lot easier. So next step, next 2 points are x0, y3, and x0, y4. So x0, y3 represents the straight line from here, x1, y1, coming down through the origin onto our projection there. And this represents, again, where this point ends up on our projection. And then we have our x4, x0, y4. And again, this is on the same x coordinate because it's on the same flat plane here. So we're going to treat this as we're going to treat these as similar triangles just because the angles that are made here are congruent there. And with this being parallel there, that should be the same as that angle. And this should be the same as this angle. So these are similar triangles. So now our height is going to be proportional to our distance that we have. So our distance, we have this distance here, if you saw those lines, from our projection to our origin. This is basically x0, actually. We have our second distance, which is from our origin, our pinhole, there, to our lamp, which is basically just x1. So we have x1 and x0. So our height is going to be proportional between basically the ratio of our height on our projection is going to be to the height in real life. It's going to be proportional to the distance here, which we define as 2 inches, versus the distance away. Now, for the sake of this, I have a lamp that's actually 5 feet away from my chair here. So I'm going to call this 60 inches. So we have a lamp 60 inches away, 2 inches there. And in this case, for the sake of adding numbers to things, I'm going to say that this projection here took up about, what is the diameter of our Pringles can? Took about 3/4 of the diameter of the Pringles can. Pringles can is about 2.5 inches, give or take, 2.5 inches across. So let's see, diameter is 2.5. So that's 1.5 plus 0.75 is 2.25 inches. So this is 2.25 inches. Now let me start to write this out a little more formally. Times D1 equals 0 times D2. We have, let's see, X1 equals 60. X0 equals -2. D1. Oh, wait, so that's actually X1 times H1, sorry. X0 times H0. So X1, H1 equals X0, H0. So X1 equals 60. X0 equals -2. H1 equals question mark. H0 equals 2.25. So we have these ratios here. So I'm going to go ahead and knock this negative sign off the X0 because we're dealing with ratios. Doesn't matter if it's positive or negative. In this case, signs are based on common sense. Common sense says that we do not have a negative height lamp, I assume. So, all right, let's see. So we have X1 60 times H1 equals 2 times 2.25. H1 equals 4.5 over 60. H1 is going to be, what's that? Was that 3 over, pull out a calculator for this, might as well. 4.5 over 60 gives us 0.075. Which does not seem right. Seems rather small. So the reason for that is I actually got these ratios wrong. The equation should be X1 over H1 is X0 over H0. So let's redo that. Trial and error, that's part of algebra. So we have 60 over H1 equals 2 over 2.25. That looks much better. So now we have 60 times 2.25 over 2 equals H1, equals our height. So bring this into focus. There we go. So the corrected equation, X1 over H1, X0 over H0. Plug in the numbers that we have into there and rearrange. So that's going to be 30 times 2.25, 60 point something. 30 times 2.25, 67.5 inches. So H1 equals 67.5 inches. And this gives us our height of our lamp is 67.5 inches or about 5'7", 7.5. So coming back here, we can generalize this equation a little bit more. So we're going to take our same numbers, same equation that we have. We have our X1 over H1 equals X0 over H0 equation. Now we know our H's, we can determine those actually. So our H1 is actually Y1 minus Y2. Remember, I defined Y1 as the higher one. And H0 is going to be Y4 minus Y3. In this case, Y4 was the higher one in our diagram. If you look there, Y1 is up there, Y4 is over there. And actually, we're even going to add absolute values around this because we're dealing with distances here. So we're dealing with ratios of distances. We don't need any negative signs popping up because it doesn't make sense unless we're talking about position. If we're looking at position, where things are, then we need that. For the sake of looking at height, we do not need that though. So we have this, and now we can expand this out. So x1 over y1 minus y2 equals x0 over y4 minus y3. So either of these two equations works. Depends on what kind of information you have. If you have the coordinates of each point, then this equation works just fine. If you have more knowledge of distances and how far things away, the first version works. Either way, you're getting the same kind of information. Just depends on how you want to visualize it, how you best think of it in your head. So I guess just to finish out on the final equation, we can say h1 equals h0 times x0 over x1, where h1 is the height we're looking for, h0 is the height on the projection, x0 is the length from your pinhole to your projection, x1 is the distance from your pinhole to your object that you're measuring. All right, well, thanks for watching. Check out my other videos here on George Sangiolo Fitness. They're a little bit less physics oriented, a little more exercise, science. Hope to get some more content out there soon. All right, have a good one.